guys, good morning. Yeah, this is Edwin Deloso. So, welcome back to my YouTube channel. So, it's been a while that I have not uploaded any video. I was able to continue with the AJIS project. Yeah, I just busy with my other stuff, my work, and then also I'm studying on a new topic, modular monolith architecture. So, I just finished my course on this from Milan. So, it's quite a very interesting topic. Course, I meant there are lots of topics that we can discuss also. So, yeah, as introduction to this MMA course, I will show you a brief overview and I will show you also what I have shared or discussed to my team regarding MMA. And if you want to learn also about this course, I will leave the link below for the full course of Milan. I think that would be helpful. But let me share to you a snippet, an overview of what I'm talking about. Okay, guys, I will turn off my video and I will share my screen. And let's go to the slide. And also in the code base, I will discuss a little bit because I believe that sharing is also learning, right? So the more we share, the more we learn also. Because if we are just watching the video, we are reading it theoretically, and we are not applying it, then that's not 100% learning. And if you cannot apply in your project yet, I mean, yeah, you cannot apply what you have started. I guess sharing it with others will also give you more knowledge because you have to dig deeper or you have to strive harder to learn the specific topic because you want to share it. Yeah, so sharing is also learning, right? Okay. So, as you can see my screen, guys, this is the project that I'm talking. So we have, this is a modular monolith architecture. So before that, let me give you a overview. Let me share you the slide and let's go from there. Let me open my slide. Where's my slide? Oh my goodness, where's my slide? Let me just find it, guys. Where did I put that? Oh, it's not here anymore. I'm just searching. So here we go, guys. This slide is learn about modular monolith architecture. So let's have a brief discussion about this. Okay, so oh, it's not moving. Okay. So the this is just a brief overview. So I have to discuss just introduction on what is a modular monolith and what are those architectural drivers that we need to consider and what architecture that we are going to use in building an application. And then what are those cross-cutting concern? The other one, two module, not discuss it. I'll just stop at the module cross-cutting concern. All right, so I think everyone heard already what is a monolith application. So that's a big application that you have only one deployment unit. So you have a communication using method calls. So it's scalable, guys, but this is resource efficient. So especially if your application is getting bigger and bigger and will introduce a lot of issues, a lot of a lot production, and a lot of issue in the code, right? Because especially if you're working with lots of developers and everyone has a lot has different approach, so you have no standard approach to do things. So yeah, that is directly connected to each other. And for example, if you change something in this module, in this particular class, and then it will affect others. So that's a big application in one unit. So yeah, it's not separated. It's just separated. I mean, it depends on what architecture also is using. Uh, programs architecture I am talking about. So usually, um, the most common for the previous years is enter approach, which is from your UI connecting to your business logic. Where the business logic mostly we have we call manager, and we just put it in the common folder. Like for example, if you have of payment, then you will call it usually payment manager, and you should just access it directly from the other business logic that you will have. And then yeah, from the business logic, you have a folder like your data access layer where this communicate to your database and of course the database. So that is the structure. But there are lots also using clean architecture. So this structure is most or much better one because you are isolating your there are different layers. You isolate, for example, your entities, value object is in the domain layer, and your business logic or use case is in the application layer, and your external system or like connecting to database is in your infrastructure and your API, or it could be controller with API or minimally API. You will put that in the presentation like that. So there is a separation of concern. So yeah, so this monolithic architecture is have an immediate consistency. Why? Let's say, for example, this is the project that I will be showing to you. So we have a module ticketing, we have events, we have user, we have attendance, payment, and orders, and you're just talking to one database. So you can see in the its module we're talking here is connected to each other. So there is an immediate consistency. Yeah, so it's good if it's just a small application, but once your application will evolve, then it could not be maintainable anymore. It cannot be scalable. So there will be a lot of issues that will be coming on. So that is why we are introducing here another architecture that we can use to solve that problem. But the question is, which one is better? Because we cannot just say that modular, this is the topic that I'm going to discuss, modular monolith or microservices are the best one. So you're familiar with microservices. It's just a small service that is deployed in different server like that, and it's communicate through network calls. So uh, so it's not easy to decide what architecture, but to make the decision, we have to consider in a given context, and what are those consideration that we usually use. Yeah, we have these architectural drivers. So these are the set of requirements that drive the design process on you over your architecture. So we have number one, technical constraint. So this is talking about the specific language, programming language that your team will use. If, for example, you have a 10 or more developers or five developers, but they have different programming expertise. There are Microsoft Stacks developers, C Sharp, and there are others, Java. So you have to consider that. And also business constraints. So this is the deadlines that we need to meet. So yeah. And functional requirement, this is the problem and how we are going to solve that problem. So we have to consider that. And the last one is quality attributes. So these are what we call LTs. So what are these LTs? Could be the scalability, maintainability, testability, modularity, everything like that. You have to consider in choosing what architecture you are going to use in building an application. So my uncle, Martin Fowler, said, you should not start a new project with microservices, even if you're sure your application will be big enough to make it worldwide. So yeah, that's we a lot of developers now. I think IT guys just talking, oh, we need to microservice this like that, but you can see the seeing of Martin Fowler, so you cannot just start it directly. So what's the reason behind? So when we talk about monolith first, so these are the most successful microservices story. I mean, the most successful microservice story started with a monolith system that grew too big and evolved into microservices. So what's meant to say that they have already existing monolith uh, application. So what are those big companies that have existing monolith architecture? They specify Stack Overflow, they are using monolith. And because it's getting bigger and bigger and it's hard to maintain, they are moving it to microservice or other one. They say that the killer of microservices is the modular monolith, and that is what I am talking about in this video about modular monolith architecture, right? So, for consideration, if you go microservices first, the system built as a microservice system from scratch will not often do worse. Will often do worse or will not be good enough, so you cannot easily get the boundaries. Service boundaries are really difficult to get it right. And boundaries are more challenging to refactor in a distributed system because we are talking about microservices. It's like a distributed system. Like, for example, the previous slide that I told you, you have ticketing. So you have to deploy this. This ticketing is a small service, microservice. It has its own connectivity or a connection to database that we call DB context. And this is deployed in a separate server. And when we talk to other service as well, so you have to go to network call or you can messaging like that. But the challenges here is how uh, your network, how good is your network, and there are other things that you have to consider. For example, how do you get the logs? Because this is talking on different server like that. So that's what we are going to discuss also in the cross-cutting concern here. So why we consider to do modular monolith. So by doing it in a modular monolith, you can get the best of both worlds. So you have the physical architecture of the monolith, especially if you already have the monolith application. So you are just going to structure it or to migrate it in a modular monolith. So if you will use modular monolith, you will have the physical architecture, meaning the code base is just in one container or one physically it's there. You can say the module there is not separated, yeah. But you can also have the logical architecture of microservices. So what is that logical architecture? Uh, you can have the like how it is being built and the time that you can consider to make it a microservice, you can just extract it from the modular monolith, right? So that's the best one. And then, yeah, modular monolith. This is the example. So modular monolith is an architecture pattern that structures the application into an independent module or component with well-defined boundaries. Yeah. In the picture, we have four modules. So you have ticketing, events, user, and attendance, and this we just have one database. And this one we are using PostgreSQL, and we're doing it in a container, Docker container. So yeah, so as you can see, to communicate to its module, you have to use a public API. So you cannot just directly, like in a monolith, that you can just directly call that manager then access it. In the modular monolith, you have to define a C# interface, and that's the way how you communicate if you get data from other modules. Like for example, in ticketing, when you want to get the user, so you have to access it through public API. That's one way, or it can be a messaging as well. So we'll just see you later. So what are those benefits when we are using modular monolith? Number one is high cohesion. So number two, loss coupling, so it's not interconnected to each other. And simplified deployment, improve performance, and lower operation complexity. And the last one is the most important one because it can easier the transition to microservice. So you just have to extract the module and deploy it in another server, and that is now what we call microservice. So the modular architecture, to achieve a modular architecture, the modules should be independent and interchangeable. So your module, you should have the specific, for example, domain that is specific to that module, your use case, your business logic, your architecture, what you are going to use, that will be specific. to your module. And the module must be able to provide the required functionality. And so we have defined interface exposed to other modules. So that's how to communicate to other modules. So module constraint is with logical isolation between modules. Modules must talk to a public API, and module data must be isolated in the database. So system becomes harder to evolve. Like you, so isolating high high coupling changes from one part of the system can be undefined scientific in a part of the system. So that is the consideration. Yeah, so we are talking about loosely coupled modules, so you kind of control the degree of the coupling between modules by communicating through public API. So isolating module in the database. So what are those isolation? So I discussed this already. The module must talk through a public API. It could be method calls or messaging like Kafka or in service bus, what messaging you'll be using. So the module data solution, there are four levels. Level one, separate table. Level two, separate schema. Level three, separate database. So you can have different database in each module. And different database, like if you're in one module, you're using PostgreSQL, in one module, you're using SQL Server, it doesn't matter. Okay. So now we go to the module cross-cutting concern. So what are those module cross-cutting concern that we can have? So if you got, let's say, for example, we have the user module. So this user module is using clean architecture, so the program architecture. So you can see there is a presentation layer, application layer, domain layer, and infrastructure, and it has dependency to the cross-cutting concern, as well as the event modules, the ticketing module, attendance module, and other modules that you can add. It should have a dependency in the cross-cutting concern. And what are those cross-cutting concern? We are talking about cross-cutting concern. There's the common uh, logic or common code that we need to share to its module. And we don't need to put that in its module because to avoid repetitive code. So redundant code. Let's say, for example, dependency injection, how you inject your services. If that is specific to the user module, you can just put that in a module. But if that is not specific to the module, which means to say it can be used in user module in other modules, so you have to put that in a we can write a common folder and that common folder, this is a class library and that you can just add the dependency that in other module. So other than that is the configuration, structured logging. So your logging is applicable not just for the user module, but for the entire module. So you are not going to put a logging mechanism inside the user module and event module, but you have to put that in a common folder so it can accessible in any module. So if you add another new module, that is already there. So you just have to add a dependency and no more coding. So reduce redundancy of code. Another one is structured logging, exception handling, validation, caching, health check, etc. So let me go to the source code so we can uh, have a clear understanding. Okay, so so this is the Evently application. So it's just a sample application, so no problem with that. So the source folder you can see here. We have the API folder, and this is the main entry of the application. I can say the program C is here. So that is the main entry on the API and the front end. So because we have this is the backend only. So let me just stop it. And then we have this common modules. So this is, for example, you have your attendance module. And if you can see that the attendance module has using a clean architecture, that is why you can have its domain. So this domain, it's organized by feature. For example, uh, attendance, so you have attendees, and then this is the specific domain that is used in the attendance. So it's separated from other module. And then let's say, for example, the application, this is the use case or business logic of your attendance. So it's separated by feature also. For example, in the attendance, you have ticket and then You have to create ticket. So we are also using here CQRS. So you can see that we have a create ticket. We have the event handler. So we can handle here tasks. And then, yeah, if you like that. And then we have also the infrastructure plus library. So this is about talking to your database external system, like because we are using inbox outbox pattern here. So we have inbox outbox here, and also the authentication. We have the database. This is how you oh, define your database. So this is specific to that module. So yeah. So if you can take a look here, this attendance modules. Let's see, where's the dependency here? Modules, and then yeah. So so let's open the application. If you take a look on the dependency of the application, you can see that it's referencing heavily common application. So that is the cross-cutting concern that we are talking about, which means to say that this logic should be shared to any module. So how we do it, we put it a common folder. So we create a common folder and we create a class library that is common to everyone. Let's say, for example, we have eventually common domain. Okay, so this domain, this is applicable to each other module. Let's say, for example, you have your entity. Okay, so this is the base class entity for all the entities that you will have. So we put that in the common and we just add as dependency in other modules. So you have not to do this in every module because if you have to do this in every module, that is a redundancy of code. So I think you got the idea. And we have also this result object result class, which is we are trying to use in the validation. We are trying to use success failure pattern. So we use fluent validation. So any modules can use this. You just have to reference it like that. And also in the infrastructure, if you take a look at the infrastructure in the common, there are these common like the configuration. That we're talking about the cross-cutting concern of configuration. If you take a look on this configuration and extension, I created a configuration extension. So this is the way that you to get your connection string. Yeah. Yeah, configuration gate connection string on or true. So you got that. And another is the caching. Yeah. So if you have, this is the implementation already. So it's talking about the implementation. But in the application here, in the application, you can also that we have application configuration. So what is there in the application configuration? This is a static class that had a add application of type iService collection. So you just pass your iService collection here services, and we have to also pass the assembly or module assembly, and we have to configure here like the add mediator. We have used mediator, so we configure the exception pipeline behavior, the request lag pipeline behavior, the validation behavior. So these things will we will not do it in its module here. You can see that there's like this in the module here that we have exception handling, request lag flagging, validation, but we put it in the common and we just add as dependency here in the module, so it will be applicable. So it's through reflection. That's why we have using reflection. And in our program that CS, we need to register the application configuration. So it can scan the assembly and yeah, it will have. So you can see that we have, let's try to find the add application. application configuration. So yeah, so builder services, add application, and because we have parameter, we are passing there, you will receive the assembly. So it's module. So we have to pass the area of assembly, this one module. So you can see that we are accessing the user application assembly and event application. So it's module assembly. You just have to pass this. And when you add application, so everything for your behavior is now accessible also in its module. So what are those behavior that we're talking about that is in the common? So you can see that you have folder behavior here. So the exception lagging behavior, this is the one. So it's just you have your exception handling pipeline behavior. So this is amendable. We are using mediator, and then it's just passing also the logger here. So we can put a logger. So it will just handle every request and respond with the API. It will be log here if there an exception. So this one we're just trying to, this is a delegate that will pass to the next request. And for the logging pipeline behavior, we have here, you have the request logging pipeline behavior. So you have your request, and of course we are also putting the logger here. This is in the uh, Microsoft extension. And this is how you put the log. So log information, and then if it's the success, because we're using result object here, and that will be passed in your API. So if it's successful, we just return that, log that, and it's return result like that. So I think you can have idea of that. And also the caching, we have here the caching, and this is the interface for the caching. This is common. So you have to put it in common, and every module can access it. So you don't have to put it everything in its module. So let me just try to run it so you can see what I'm talking about. So we have containerized it. So you can see also that we have Docker Compose YAML here. So this is how you define your, like for example, the API services, the Heavenly API. So we are using the image here, Heavenly API, and then the container there, Heavenly API, and like that. So we are using port 900. So if you run this, even if I don't have installed, for example, the Postgre in my local, we can use the Postgre because uh, we use the Docker container to do that. So let's just wait. So I just scan what our compose file. So for example, the database, the image is Postgres latest, and the container is evenly that database, and this is the environment that we define. So in my container, in my Docker, I installed my Docker here. You can see that we have this Evently database, Evently identify, Jagger, C for the structured logging, and the Redis for our caching like that. And yeah, our API is now running. So you can see that this is the sample. And let me share also the structured logging, how it's done. So the structured logging, if you can see in our structured logging here, we can see in our what we call this in the app setting JSON. So we can just take a look how it's being, what is the address that's in it defined. So this is the connection string. This is the connection for the cast, and yeah, authentication we are using keycloak here. Yeah, that's a keycloak here. So serial log. So this is how it is being configured. And yeah, so this is the name that is structured or set up in our container. So I'm talking about what's the address, the port. So we can go to the container, Docker container for the SIG. Let's me find what's the port or the IP address that we set up here. SIG latest, the port 8081. Yeah, 8081. So 8081. So it means This is our API, so we can access the structured logging through 8081. So yeah, so that is the structured logging, guys. So you can see the it's being logged every request and every respond. Let's say, for example, because this is modular, we have module. We find a module, let's say, module equals user. So it will just give you the log for specific for the module of user. That uh, what happened? You cannot see user. Mm, we cannot find it. Let me tell you this. We cannot find it. So yeah. So let me register a user and can see the logs. Maybe there's no log yet with the user. So for example, here we have to register the user and then to see the log, how it is being logged. Say for example, this gmail.com and then we have our password, it's a 6 character, and then we just paste it and it's logging here. So because we are using inbox outbox pattern, so that will be discussed. If you want to learn more, so you can just have. So we have success response here. Then now I think we can have a log for user. You should have user. Yeah, so you can see that there is a process request here. So registered user command, and you can see what application is even the API and the connection ID, the module is user, the request ID, and what's the request name, it's log here. So this is your logging. So what request what is logger for this is for debugging purposes. And if you take a look here, so this is the span header, so everything you get the query, yeah. So you can see that this is a pipeline behavior that's being used, and the completed request, yeah, that. So yeah, I think and another one that I will show you is also the health case. So health check. So let me get to the postman because we have also added a health check. So you can see in our program that says that is also one of cross-cutting concerns. So defining health check. Yeah, so this is how we register the health check. So you just have the new get bucket for health sectors a lot. And since we are using PostgreSQL, we have to use Postgre health check like that. So we have configured his the health check and the connection to the database, Redis, and yeah. And of course, we have to add the map health check here and we, let me take a see you. This is the example of health check. So I just see that you can see it will determine that your certain API here is running or not. So it will be healthy or unhealthy. So from that, you can have an alerting system that will inform your user or even your the developer. So you are aware that your system or your certain API is not running, not with not with for the your customer or your client to say, hey, why you cannot access this API like that? Yeah. So you have to, yeah. So this is what I'm talking about. Let's say, for example, our database, for example, a healthy is running, or Redis is running. But when I go to the container and let's see, I will stop the Redis, this one. I will stop that and let me run again the health check. So it's that's healthy. Now it's well unhealthy. It's meant to say you cannot reach your Redis container now. So you can see that Redis data and the description, the connection exception, the message timeout. So you cannot access. So from that, you can have an alert system that will send to you that, oh, it's not working now. So you have to fix it before the customer can find that it's not working. So it's thing like that. And also for our Redis, you can see how we implement the Redis caching here. We are using the let me just go to our Git category as a sample of how it's. So yeah, so by the way, we are also using minimal API here. So this is the API from the Git category. So we're inheriting the I endpoint uh, interface, and you can see the method map endpoint where we are receiving the I endpoint route builder. So this is from Microsoft ASP.NET Core routing. So this is the routing. So in minimal API, we have, because we pass the router builder here, so we can access app.mapget. So mapget is a HTTP get. So you define your API name here or address the categories. And to make it async, we have to put the async keyword here. And this is the parameter injection because we need the sender. This is coming from mediator because we are using CQR is here. And also we inject here the ICAS service. So we can use the casing service that we define. So you can see here, this is a read-only collection of category response, and you have to call the cast service it async and then what category respond and the categories. So if that category span is not null, it means to say that you have a cast for that. So you have to just and return the category response for that. So you are not accessing to the database because you already have the cast data. Where if this is null, so there's no cast categories respond yet. So you have to read it from send it from the data. So yeah. So this is the git categories query, and because I think if it's success, result is success, so you have to save it in the categories, the result value, so you can also use that in a later request for others. And then, yeah, also the required authentication permission, that is how we access the minimal API. As you can see here, how we configure the minimal API. You can see in our modules. So the minimal API and the module that's, for example, in the user module, API is in the presentation layer. So presentation layer, and let's say, for example, in the user, this is how. So this is your minimal API as a user. So you can see you inherit the IF and how that goes to the main folder of the program. So in the API itself, in the program that CS file, we scan the registry. So we have to add map endpoint. And if you try to look on that, what is that? Map endpoint, this is a static application, a static method that return an application builder. So we accept the web application and the route group builder, and then yeah, so we scan the endpoint using the get required services of a endpoint, and then the endpoint builder snarl, then we loop that and save it to the endpoint to builder and return the app. So everything from even in other module, it will now be accessible in the main program because of this map endpoint. So this scanning assembly in this module. Yeah. So I guess that's just a little way of discussing what's a modular architecture. So what in the previous discussion that they can easily extract into microservices. So what I'm talking about that, for example, this ticketing, you want to make it a separate it will not be in here in logical structure, but you put it in a separate structure and you deploy it in different service. So that is now what we call microservices. So it can easily be extracted, and you just have to communicate it through network call. So in this application, we also introduce reliable messaging. We have inbox pattern. You can see that we have event bus here. But I will not discuss it, the integration. We have messaging here. So if you're decided, I highly recommend that you watch the full video for this, the full course, and I will put the link on the description. So yeah. So thank you for watching, guys. This is just an introduction. So I hope you have a little bit idea on that and you will be inspired to take the course, right? To learn more. Bye bye. Thank you. Don't forget to subscribe and hit the bell button so you will be notified for the other sharing that we will have. Bye. Awesome, awesome day, guys.